Hello everyone. As mentioned in the last bit of previous class, today we'll discuss software tools for 3D concrete printing, starting from an objective modeling, generating G-code from slicing tools, and host interface which controls and manipulates 3D printer. The initial step in 3D printing involved concept design and 3D modeling, typically executed using computer-aided design software, which is CAD software, such as Autodesk Inventor, Blender, Rhino, and others. So I will explain the several software options, both free and paid, that cater to different users levels and purposes. The first modeling tool is called ch5.3 CAD modeling. This software has a very user-friendly interface for both hobbyists and professionals. Very easy to create and redesign the shapes. You can work on an iPad if you have one, which I think is a really great feature to have. This software offers visualization features allowing AR-based previews for perfect print alignments across iPad, Windows, and Mac. The second tool is called Blender. This tool is completely free of charge and open source based software. And this tool is already very famous in different fields than just like a simple the modeling purpose, such as for animator, simulator, and someone needs great rendering feature, whoever uses 3D design extensively. So the only hurdle you will get is a steep learning curve, but once you pick up with the fundamentals and advance yourself, the software allows a user transitioning to complex 3D modeling and also offering features like photorealistic rendering. The next one is FreeCAD. It is a freeware and an open source parametric modeling tool that enables the design of the real-life objects. The software supports almost anything you can think of in the paid version of the Autodesk CAD. The software also has a parametric functionality that simplifies model editing, making it a useful learning tool. But you'll still get some limited capabilities if you're looking for some professional features that you could get in the paid CAD software. The fourth tool is SketchUp. This tool has a very good balance in usability and functionality. SketchUp suits diverse skill levels with proved that the widespread of users. It excels in architectural projects and provide advanced features for professionals with versions available for both free and paid access. So finally, Autodesk products like Inventor or Fusion 360. The Inventor was developed for 3D CAD drawing for 3D mechanical design and parts manufacturing and so on. The designer has so much freedom in creating a desirable object with a help of parametric modeling options. The powerful part is that you can integrate different packages and do so many things with it. And Fusion 360 is a cloud-based CAD program and basically integration of many parts of Autodesk like 3D design and modeling, CAM, electronics like EDA and PCB, simulations like FEA, generative design, and real-time team collaboration, and most of all, additive manufacturing like 3D printing. The interface is fairly similar to Inventor or other Autodesk products. So if you're already an Autodesk user, you will have a much faster learning pace for this. The next and last modeling software tool that I want to introduce is Rhino 3D. This is known as a versatile 3D modeler. The Rhino 3D uses the non-uniform rational basis spline mathematical model, also called again NURB, for precise and more the models. Or then the models this mathematical model precisely manipulates the points, curves, and surfaces and more. This software has a number of strong plugins and so many extensive features. While versatile, it requires a learning curve and due to its detailed capabilities. Following that, you'll have a 3D model file saved in different forms, but mostly saved in .stl, or sometimes you call it STL file. Now you need to convert the 3D model into 3D printer readable file. The converting process is called slicing. The slicing tool plays an important role in producing accurate and solid printed objects. These tools streamline the process from a 3D model to a printed part by dividing the CAD model into layers and converting it into G-code. Additionally, slicer software incorporates 3D printer settings such as temperature. In our case, not using temperature, layer heights and print speed and so on into the G-code. The 3D printer reads each line of G-code to construct the model layer by layer, adhering to the instruction embedded within it. There are various choices you can go for, either paid or free software. The first slicer that I want to share is Ultimaker Cura. So this slicer is an open source software developed by a 3D printing company, Ultimaker, but compatible with various other 3D printers, or you can build your own custom-built 3D printer settings. It's beginner-friendly, featuring an intuitive interface and the rapid operations. While easy to use, advanced users can access around 200 settings for finer print adjustments. The next go-to choice is a Simplify 3D. This software is considered a premium slicing tool. Simplify 3D not only slices 3D models, but also corrects any model-related issues, offering a preview of the final print. Advanced features aims to significantly enhance print quality. The only drawback is its premium pricing compared to open source alternatives like Cura and the Slicer. Another open source software slicer is called Slicer. So this has quite a history and it's being used by many other users. The software supports fundamental settings with boasting real-time incremental slicing, a 3D preview, and some other more. Its incremental slicing features allows for faster adjustments without restarting the entire slicing process. This results in a swift and adaptable, accurate slicing experience. In some cases, for special purpose, some users have developed specifically for their own application, such as 3D concrete printing field. A number of 3D concrete printed manufacturers have their proprietary slicers integrated in as Rhino 3D Grasshopper plugins. Examples include Chisel by ch5.3 and Salad Slicer by TU Eindhoven, and Vitvian and Vos. So these specialized slicers often feature parametric modeling tailored for concrete printing, aligning with the specific needs of this niche. Finally, there's a host interface, which serves as a connection and communication link between your 3D printer and your computer. It allows you to load your G-code for printing or manually input G-code commands to control the printer's movement and the functions. While many slicers programs include host interface features like Ultimaker Cura and Simplify 3D, some software is solely dedicated to providing this functionality. For example, a Pronterface stands as a straightforward graphical user interface facilitating printer monitoring and control from a computer connected by USB. It enables direct manipulation of stepper motors, regulation of bed and nozzle temperatures, G-code command transmission through a terminal or console window, and more. This was developed as part of the RipRap initiative. Pronterface, an integral component of the printer run suite, has a long-standing presence within the 3D printing and CNC community. Despite its minimalistic graphical layout, the software has retained its utility and popularity. Originally designed for comprehensive control of the 3D printing workflow, including slicing through slicer, so the Pronterface has transitioned into a more focused role. Nevertheless, it maintains distinct advantages over other software options like Octoprint and various G-code standards. Its compatibility across the Windows, Mac, and Linux systems, coupled with its simple installation and user-friendly interface, especially for basic functions, remains noteworthy. Moreover, its customization capabilities for automating repetitive tasks and its Python-based structure offer technical users the flexibility to make personalized modifications. That's it. Today's discussion navigated through software tools according to the workflow of 3D printing, from 3D modeling and the slicing and running and controlling the 3D printer. I can recommend that you can build up your proficiency as you play around with those softwares that I mentioned earlier before going into real printing. I hope this video helps you understand better and the tools you are using for a 3D printing process. We can finish up this week and we can carry on in the next week, which is structural design aspect of 3D concrete printing. You probably noticed this week was more aligned to generic information for 3D printing, but we'll get back to our own focus. Keep well and see you in the next video. Bye for now.